Good morning, everyone. I think it's a good time to start. The wave of entries has crested and receded, so we'll get going. I'm Dave Halsing. I'm the executive project manager for the South Bay Salt Pond Restoration Project, and this is a webinar that we're going to do in an occasional series on some of our different science and monitoring and adaptive management efforts. So I'm sort of emceeing. It's another acronym. I'm emceeing this today. Ariel Ambruster is our public outreach coordinator. She's here to do tech support. So if you have any questions or problems with Zoom, if there's something you don't know how to do, you can either put it in the chat or text her offline. She's going to enter her mobile phone number into the chat window now, and so that'll be there. Our speaker today is Brian Fulfrost from Fulfrost and Associates. He's got a presentation that's about 35 or 40 minutes long, and we'll do questions and answers at the end and discussion. I'll host that. We do ask you to hold your questions until the end, but if you want, you can enter them into the chat, and we will use that as a sort of a work list of questions to go through at the end. Please do mute yourself when you're not speaking. When we get into the Q&A and the discussion at the end, we'll try to use the raise hand feature on Zoom, and if you don't know where that is, you can go under the reactions button at the bottom of it's on the bottom of most screens. You click that, it opens up a little window, and one of them is raise hand and lower hand. So we've all been doing Zoom for 15 months now, so I imagine people are pretty good at it, but just in case, I like to cover those little protocols. So I'll stop there and turn it over to Brian. Brian, why don't you do a self-introduction and then share your screen and take it away?
Great. For those who don't know, I'm Brian Fulfrost. I've been working in geospatial for more than 25 years, mostly in conservation and sustainable planning, and working in the last about 15 on the Baylands in San Francisco, mapping the mudflats all the way up to the estuary upland transition zone. Currently in Portland, Oregon, not Portland, Maine. So I'll share now. Hopefully this will work. Okay, everybody can see, I assume, yeah. Well, great, thanks for everybody for attending. Today I'm going to talk about the 2009 preliminary results for the Habitat Evolution Mapping Project 2.0, which is an update to the first project between 2009 and 11. Thank all the sponsors, funders, and partners. We really appreciate everybody, including Chris Benton, who provided this amazing kite photograph of A21 in Drawbridge. Also thank my big partner on the project and the lead biologist, David Thompson, who was instrumental, although maybe not as actively engaged as he has in the past. One thing to note is that these results are preliminary. It's a 2-year project, as we're going to learn. I wanted to give a presentation about where we are in the project, but before it's time, the COVID and 2020 kind of got in the way. So I'm going to provide a little background. I think everybody here has really good knowledge about the project, but what is the Habitat Evolution Mapping Project and what are our goals? The goals are to track the evolution of tidal marsh habitats, which are really the vegetation and mudflats south of the San Mateo Bridge, not just in the restoration units. And that includes tidal marsh, salt, brackish, and freshwater marsh habitats. We map those as vegetation and alliances and associations. Sorry, technical difficulties. And big goal of us is to map the floral colonization of restored ponds, which we're going to see a lot of today. We're also interested in the mudflats, mapping the extent and distribution of mudflats, and if we can, the presence and distribution of biofilm. We do other things, including map invasives like pepperweed. We're working on overlaying our data with the invasive Spartina project to distinguish native and invasive Spartina. One thing I haven't done and always want to do and will do is map all the channels, because the data really makes it easy to do that. Okay, so the Habitat Evolution Mapping Project 2.0 is a 2-year project, which was originally slated for 2019 and 2020. This thing called the pandemic got in the way mostly. So we're doing our second year in 2021. It's an update to the original hemp project. Some of you here were involved with that in 2009 and 11. So we'll get a kind of a decade snapshot. We're already, and what I'm presenting here is what we've done already for 2019. It's a bunch of stuff we did with the imagery. We got a great image, which you'll see on June 8th, 2019, just at mean lower low water from the WorldView 2 satellite. We processed that, geo-corrected it, orthorectified it, pan sharpened it to 0.5 meter, and did quite a bit of surveys, almost 300 surveys over the last 3 years. We did additional work this year to calibrate. And from that, we produced these preliminary habitats and mudflats. We've done a preliminary change analysis between the 2009 data, and we did a preliminary change analysis for mudflats from our 2016 pilot project. We could not map mudflats from the previous time as a baseline because we did not capture the tide consistently. So we updated that in 2016. So here's the image we got and the study area. Again, I think everybody knows here, this San Mateo Bridge is up on the kind of thin line on the northwest of the image. We're looking at this in false color because red is showing us chlorophyll and the greenness of vegetation. And we can see the restoration areas of the project as well as the other marshes and mudflats. The mudflats appear really clearly in this image. So we really did well. And as I'll talk about, we got another good image this year. So just a little background. In 2009 and 11, we mapped about 15,000 acres of tidal, salt, brackish, and freshwater vegetation, which are really proxies for the habitats we're interested in. The low, mid, and high salt marsh, brackish, and freshwater. And then in 2016, we mapped about 18,000 acres of tidal mudflats, shown here in brown. We used WorldView 3 imagery and some different kinds of processing, which I'm not going to go into great detail here, but certainly happy to ask questions about. So then in 2019, we updated that data and we have now preliminary results for that. We have acreages of tidal marsh between the original 2009 and 11 and 2019, as well as mudflats. And we're currently working on the 2021, and I think we got an image. So I'm really happy about that. And we were looking at the results here. You know, at the scale of the study area, it's very hard to see a lot of the results, but I show the images anyways. It's sort of the colored stuff, the brown and the green, right? But we're going to zoom in, you know. So I just find that it's good to mention that because it's often very difficult for those like those here who have very keen eyes about the area might be able to pick up stuff at this scale. So I'm not going to make everybody snore. Maybe a couple people would be excited about the methods, but I'll go over them briefly and happy to ask questions about them because really we're going to look at results here. But the methods are similar to our previous work. They're based on an analysis, a spectral analysis of high resolution multispectral satellite imagery. So we're really dependent on sensors that have that capability. And we do extensive ground truthing. And I say that because for a remote sensing person, when you give I've given talks, they scoff at the amount of ground truthing we do, because they say, we're doing it remotely. We don't need you to be on the ground. But I think that's essential to getting a good product. And we can use that ground truthing in various ways. So step one is we develop the habitat or vegetation classifications, which we really did in the previous study. And we're using those classifications from the previous study that really David Thompson helped develop as a foundation for our work. So we didn't really have to do much of that this time. And then the second step is to acquire the satellite. The big challenge that we have is timing satellite flyover, which is about noon with mean lower low water between May and August, which is much more difficult than it seems, especially since the satellite company isn't always cooperative now. But we still got an amazing image in 2019 and also a great image this year, so we've done well. The 2019 and 21 images are from the Worldview 2 sensor, which is 0.5 meter spatial resolution. And our previous work was a 4-band sensor, which included the true color, red, green, and blue, but also near infrared, and it was 1 meter spatial resolution. So once we get that image, really our next big step, other than these other pre-processing steps, is to run this spectral classifier of supervised classification into different habitat classes based on training sites that represent each habitat class. And then it'll map the whole image. You know, is it all pickleweed? Is it all Jalmea? What's there based on our training sites and our habitat classes? We ground truth that. We look at the results in the lab. We say it's good or bad. I always use the case of very early in the project, Meg Marriott told me, you know, Brian, that part of Outer Bear has no gum plant. So I learned from that, improved, that was very early on. And we do that iteratively until we create a result that we like. We do a mix of methods for mudflats to optimize tidal variability. We map the extent and distribution of mudflat that way, not the presence of biofilm. We do the presence of biofilm within our habitat model. And once we're happy with the habitat model, we validate it with a stratified random sample of ground truthing, and we had 180 points for our 2019 image. What are these habitat classes? What I've learned is when you copy and paste from Excel into PowerPoint, it creates a green background, which I've kept here. We mapped 19 habitat classes. It's slightly less than last time for a number of reasons, because we did not get a good differentiating certain habitat or vegetation associations, distinguish them well. So we decided just to start with the ones that worked well. We have 7 salt marsh habitat classifications, which are all shown on the right, 2 brackish, 2 fresh, 3 upland, which really include pepperweed, and 5 non-vegetated classes. And so those 19, we mapped those 19 habitat alliances and associations, and then we can scale up to these other broader habitat classes. And I've done that here in the presentation for clarity purposes. The acreages are summed to the salt marsh low, salt marsh mid, or salt marsh high, brackish, and fresh marsh. We have the data at all scales, but we've summarized them in that way for ease of interpretation. So I just wanted to include one slide about the satellite image itself. It's an 8-band sensor, which is shown here on the top right, includes the panchromatic brand, which we use to, the multispectral data is really at 1.8 meters. We pan sharpen that fancy term. We use this other band called the panchromatic, which crosses many spectra, which is at 0.5 meter. We kind of combine them or fuse them to create a multispectral image at 0.5 meter. The sensor is world-class sensor because of its spatial and spectral resolution. There are new sensors coming on board these days. I've learned about planet.com has a new 8-band sensor coming on board. So that's really going to expand. This is a rather old sensor, and they have an updated one from called Worldview 3 that's slightly better, but we don't need it for our purposes. There's a little thing here that compares the Iconos to the Worldview. Iconos is the first image we used. There are only 4 points along the electromagnetic spectrum we can get versus 8, and the 8 really helps us with the mud flats and the vegetation. It's definitely an improvement. So, I've been talking a lot of slides with words. So I'm throwing a bunch of pictures in here, and here are images from 2019 in false color. And these are mostly restored mud flats, and then the one pond in Eden Landing that I just think looks neat. Which is really, we know, bottom reflectance. It's full of water and we can see the bird islands. But here we have A17, A6, the Duck's Head, the old Bomberg track, and E9 and E8A, which we're going to look at the results here. But really, the data was really impressive. We got the image at a really good time and provides us a lot of ability to discriminate vegetation. The vegetation in some of these ponds isn't that colonized yet, but the image is really great, and I'm hoping can be used by partners in other ways if it's useful. So I'm just showing here another again, and from that image, we produce our results, the 2019 habitats throughout the study area. Once we get a result, I just wanted to show, we actually did 295 surveys, 180 were validation, all done in 2019, mostly within Marsh when we're allowed in mid-July, but some from levees, boardwalks, and our boat. But we did quite a bit of calibration this year, the beginning of the year, because we didn't go out much last year. But we really get a good distribution across the study area, and I was pretty happy with how much ground truthing we got. It really helped build the model. And we have an extensive photo documentation from these ground truthing points. So we use the validation data set to build an error matrix. This is a classic error matrix where we compare our reference data, the ground truthing in the field, where we use the California Native Plant Society's rapid assessment and releve methods to do ocular assessments within a 20-meter radius of a mapping grade GPS. We get good ground truthing data, and we compare that to our classified results to get different kinds of accuracies, and including also calculating statistics like the kappa statistic. And our overall accuracy this year was 82%. That doesn't mean each habitat class is at that level. We don't really have any or good ground truthing data for Frankinia. That isn't entirely true. So I'm hoping to go back. This is why these data is preliminary. I think we can definitely add ground truthing with that one habitat where we're missing some data for the validation. The data is there, I just need to mine it better. But that 82% accuracy is at the alliance level, so it's not at the 19 classes, it's really the 15 classes. At the 19 classes, we get a 73% accuracy. An example of where we merge for the 19 to the 15 is, instead of having cordgrass and cordgrass pickleweed, we have just cordgrass. So that's an example of how we do that. There isn't as much difference this time because we've limited some of the classes that just didn't map as well. And, I did include the kappa. So our results are really good. They're 82% at the Habitat Alliance level and 73% at the association level. Somewhat expected because we got better data and we limited some of the habitats that weren't mapping as well. And the kappa statistic gives us an understanding of how much this is from random. And both of these mean that it's very high confidence that we're mapping things, not just from random statistical pattern. And it's good that it's an improvement, not a decrease of accuracy from previous years. Okay, I'm going to get to some pictures very soon. So what are some results just qualitatively? The mudflats, I think one thing we really want to know, despite the numbers shown here, which shows a reduction from 2016, which is really a product of a number of things, overall, and you're going to see the extent and distribution of the mudflats between 2016 and 19, no big surprise, is relatively unchanged. And that's in the tidally mudflats exposed to the bay, completely exposed to the bay. Multiple small locations of accretion and erosion. One interesting thing, and I think this is kind of obvious, is that the mudflats within the restored ponds have been reduced. And that's because those are the ponds undergoing floral colonization. So we see a reduction of mudflats where there is within the ponds. One number here that might be adding to that is in 2016, we showed mudflat within SF2, which might or might not have been there and not in 2019. So that's more change that might not be erroneous. That might be erroneous. But again, a lot of that change is in E9, E8, even Bomberg, and the island ponds. We're seeing more floral colonization and less mudflat. Another thing is, I see a big distinguishing marker where almost all of the ponds, restored ponds, are the mudflats in those restored ponds have biofilm on them at much higher densities and distribution than, let's say, on the mudflats exposed to the bay. The mudflats exposed to the bay also have biofilm on them, but the signal is really clear within the ponds. It's almost a lot of biofilm on top of those mudflats. So here's the 2019 mudflats in orange. And the black line is the 2005 mean lower low water line, which USGS uses as the edge of mudflat, and so do we. And you can, although it appears like in below Eden Landing, there might be some increase. This could be differences in method. But generally, we don't see much erosion. And we really see a lot of correspondence with that line. You know, they're relatively unchanged. And so this is now comparing 2019 to the 2005 mean lower low water line. And then here's our 2016 mudflat, which wasn't part of HEMP 2 directly, but was because we wanted to develop the method before we did this. And it's also very similar, okay? So I really can confidently say I don't see the mudflats eroding much, certainly between 2016 and 19, and likely even from 2005. There's some localized location. There are some locations. For the habitats, what have we found? Not a big surprise, vegetation composition and distribution is persistent, but one thing we found is a growth of brackish marsh in and around an alviso, pretty clear. In the restored ponds, we see significant floral colonization in many of the ponds listed here. I'm sure not a big surprise to people. Mudflats formed in some with less floral colonization than other ponds, but really healthy developing mudflats in those locations with, in some cases, some significant patches of pickleweed or spartina, but less so than some other ponds. And the other thing I noticed, which we're going to see, is a growth of low or mid marsh in the fringe marshes outside of the restored ponds. And I think these are also locations that people be aware of. That also can add up to a slight decrease in the mudflats over large areas. It just adds to that numeric difference. As far as invasives go, and this is really where I'm interested in what we see in 2021, our data shows a pretty significant reduction in pepperweed, but a persistence in its extent and distribution, so that although it might not be as thick, it's still there. Part of that also could be phenology at the time of satellite overpass, differences from year to year, the date of the image. But you know, it's persistent, it's still there, but it seems less so. At the same time, see a big growth in spear scale, especially in our ground truthing data. So even though something might not, you know, we might not see it in the habitat classification always, we saw it a lot in the ground truthing, but definitely see a big difference in spear scale from 10 years ago. I think, as a lot of people have said, they've seen that same thing. Okay. So, you know, I'm going to go through these charts quickly. I'm happy to go back to them. Really, I've talked about the trends. One thing we've noticed is that we need to clean up our data from the previous years. There are issues that I think are noise in the signals here, that obvious things like alkali grasses being mapped in the mud flats, which were likely not there, or water being mapped as vegetation and somehow got included in the acreage counts. And then obviously there are differences in mud flats and water. So we're working on those things. So 2011 is sort of is one year that we think is somewhat anomalous, which we think we can fix. But you know, one trend overall south of the San Mateo is we see a growth of low marsh, an increase in alkali bulrush, and a decrease in pepperweed, as I said, and an increase in ruderal vegetation to some degree. And that's shown here in that little pink. For Alviso and Eden Landing, so this is the whole restoration unit. And again, if I kind of ignore 2011, you know, in Alviso, you know, the low marsh itself, you know, maybe there's an increase or it's about stable, but we see an increase in mid-marsh and a gradual increase in high marsh and an overall increase in alkali bulrush, especially if we think of 2011 as potentially anomalous. and then again, a reduction in pepperweed. So, you know, and I say alkali bulrush. I'm actually misspeaking. The orange is what brackish marsh would include spear scale. We've included spear scale in that. So part of that increase could be spear scale. And we have that data as well. I didn't show the table with all the habitat classes because I thought it would be too much to tell. And that's in the report as well. And then Eden Landing, we see an increase in mudflat because of Bomberg, E9, and E8A. It's very obvious. We also see an increase in pickleweed in the mid-marsh and a slight increase in low marsh, and it kind of flows with what we expect. And then I think a decrease in pepperweed, but an increase in ruderal. So it's possible that some of that pepperweed is being mapped in ruderal. Our ruderal is a kind of a conglomeration of peripheral halophytes, things like radish, mustard. So it's sometimes hard to distinguish those. But the signal seems pretty obvious about in the restored ponds. Okay, enough charts and text. Here's, we're going to look at change graphics now. So here we have Bear Island. We're comparing 2010 and 2019. I mean, one thing is Outer Bear is very persistent and similar. And I've looked at it pretty extensively, zoomed in. So Outer Bear and the broad mid-plane of pickleweed is really relatively unchanged. The two parts of middle and Outer Bear that were breached, we see a change in that middle bear where it's now a giant mudflat and a really healthy mudflat, and the tan color is biofilm. So the brown here up on the top is mudflat, probably has biofilm too, maybe, but are not mapping as, but very clearly within the pond it is, right? And you see that difference here. But there's been some vegetative floral colonization, but not a huge difference, really. So I don't see that huge difference there. And certainly in the lower part of Bear where it's been fully restored, it's moved from, alkali grasses and pepperweed to now mudflat and pickleweed forming in those locations. Okay, that's down here on the bottom. I've got a lot of images, so I made choices about what I'm showing. For the partners in PMT, this is not the last time we're going to be able to look at this stuff. So we can get back to that. But not much of that is a big surprise. And I don't want to undercount, there has been some floral colonization here, like in that western part of Outer Bear that's bigger than previously. So that it looks good. It's not as much as, let's say, the growth I've seen in A21, which I compare everything to. This is A6, the duck's head. We see some, the kind of bright green and is cordgrass, and the regular green is pickleweed. So we see some floral colonization, some mats forming on the pond, but still it's dominantly a mudflat. But certainly compared to 2011 on the left, where we had the mudflat just forming, the breaches had been done, I think that year or the year before. We see a mudflat dominated by biofilm with pickleweed forming along channels. When I see this speckled stuff here, it seems, when you zoom in, it's like little tiny patches of pickleweed. And so, it's like maybe the mat is forming there, versus when you look along a channel, it could be denser. There's a denser formation of that pickleweed. Okay. So we've got a lot more to show. So this is the top of A6. So this is that marsh, and I think this is Alviso Slough here, and then Coyote Creek on top. And the key thing I've noticed is the mudflat is really unchanged, even though I don't really like to use the 2011 for the extent of mudflat, but the marsh has grown about 30 meters north. And I don't think on this eastern end of the duck's head, and then all the way on the western side of the head of the ducks, it's like about 8 meters of growth. So the growth is more so on the mouth of Alviso. And then one thing I also noticed, not noted here, is that the marsh, the fringe marsh in Alviso has grown about 6 to 8 meters onto this tiny little mudflat. It's not shown much here, but the little mud flat that goes along the fringe marsh in the Alviso Slough has been colonized by vegetation in the intervening 8 years by about 6 to 8 meters. So here we have 821. In 2011, we had the breaches. This pond showing a lot of biofilm at the time within the pond, and pickleweed with spartina forming along the channels. That beautiful image that Chris Benton has. And here's my fancy slideshow here. And then by 2019, orange here is alkali bulrush. We have an alkali bulrush marsh formed with lots of pickleweed and spartina. Now, for those who have been in this pond, this was taken really at mean lower low water. So the channel here is got water in it, but it's just in the middle of the channel, and a lot of it's mud shown in the image. Uncommon because it's at such a low tide, which is what we want for the image, but really developed into a big brackish marsh, which I didn't expect or anticipate. Drawbridge, although we can't see the other image, had quite a bit of pepperweed. This reddish is pepperweed and spear scale. So it's still there, but it's slightly less dense than it was. It appears at the differences in time. It's very clearly there. It's also like in these channels here on the marsh to the western side, it's red and it's pepperweed and spear scale, where there we were mapping mostly just pepperweed before. Here's A19, giant mud flat in 2011, some small patches of pickleweed in green, a lot of biofilm on the thing. And here's one thing that was a surprise to me. So the purple is freshwater thules, is freshwater bulrush. And we see some more pickleweed and spartina forming along the channels, and then patches of alkali bulrush in orange. And then when I was talking to our field crew, courtesy of SFBBO, we were thinking, who had been out there recently, like, no, that's probably wrong, those freshwater thules. And we got feedback from the otolith lab at Davis. They sent us pictures a week after the image was taken with the huge freshwater bulrush marsh shown here in purple. And so I don't know why that's a surprise to me, but it was. And they let us know that they think that marsh appeared within the last 3 or 4 years, right? So even though we were showing an image from 2011, that little freshwater bulrush marsh likely formed more recently. And again, in Coyote Creek Marsh here to the right, we see red and pepperweed with some spear scale, but less so than previous years, right? Less dense, so definitely still there, but less prominent. I didn't show Coyote Creek Lagoon. Coyote Creek Lagoon has also had floral colonization of pickleweed, spartina, as well as freshwater thules. And I had to make choices, so I didn't show that one, but some significant changes from 2011. This is Ogilvie Island. I don't know why I'm obsessed with this. Everybody knows about it, but 2009 on top. This is the eastern part of Ogilvie. By 2019, it's really developed into a big pickleweed marsh with cordgrass. And one thing you notice in this orange is sort of the bulrush is starting to move in or pressure the island and that marsh that's forming. And in Calaveras, we have about a 40-meter growth of low marsh heading south onto the mudflat. And it's probably a little more than we thought. I was a little surprised by it, but it's pretty clear in the image that it's moved that much. It could be more. I did an average of the growth. But you can see here it's starting to get close to the edge of the mudflat too. But there, I like to show change here. Faber and Laumeister, 2011 on the left. This kind of pinkish bubblegum color is high marsh. It's gum plant. It's a little less here, but again, it's really clear in the image that there's big locations of high marsh within that marsh. So we don't see much of a change. But one thing we did notice is in 2011, we didn't really see or record any alkali bulrush, but in 2019 we did. It's a little hard to see at the scale, but on the east, and we've undermapped it a little there, I think, but it's clearly along the channels and forming into larger patches. I don't know if that's annual variability or a general trend of salinity. It's very hard to say, but clearly we didn't notice that in 2011 and previous years, but we did. It's very clear this time. And in fact, bulrush is found. We found it in some patches around the marsh, but mostly in the southern end. And Eden Landing, E9 and E8A, I mean, I really would love to know what, I think that we see great development of floral colonization in these ponds. In E8A, the green, they're developing into large mats. They're not just forming along the channels. It's kind of hard at this scale. There's cordgrass there as well, but mostly pickleweed. And in E9, it seems less than it actually is because there's a lot of spots of pickleweed that are formed. So if you were to look at it, it would look like a dispersed pickleweed mat. And so that this scale, so it's definitely there. It's starting to form along channels, but less so than E8A, but certainly it's developing. And from my 10,000 foot view, it looks great, from what we had hoped. But whale's tail, I didn't see much change. Again, I'm selecting things for the presentation. I wish I could show everything. And the Bomberg tract, one thing I did notice is the 2011 on the right. If you look at the middle part of North Creek Marsh, there's been a significant growth of pickleweed and cordgrass within this marsh. And again, at this scale, it's hard to see the cordgrass. There's definitely thick patches of cordgrass there too, and it looks all green pickleweed at this scale. But a big difference from 2011. Not as much difference in Mount Eden Creek Marsh on the tidally part on the west. Certainly mudflats and some pickleweed, but in the muted part, we don't see as much change. And here's this 2011. I'm trying not to focus on error. The pickleweed here in the muted part of Mount Eden, I think, is erroneous. I don't think it was there. That's one thing we noticed is pickleweed in 2011 mapping on what probably is just mudflat. But I thought otherwise this image showed a really good change. We know that the changes in the central part of North Creek are real. Okay, so it's a lot of images to take in. Where are we now for 2.0? It's a 2-year project. So we're gonna, I think we got an amazing image on May 3rd, a little earlier than we wanted, but close to mean, really right about mean low or low water, no cloud cover. We've just begun some ground truthing. We wanted to get close to the time of acquisition. We're gonna use that to map the habitats and mudflats. That'll give us a check on our 2019 data, maybe change things like, no, pepperweed's definitely there, Brian, maybe we need to look back at that. And then clean up the noise in the previous data sets and distinguish between native and invasive cordgrass. And then the beginning of next year, we'll produce our final results for 2021 and 2019 and our final change analysis. So one thing I want to mention to the PMT and really the partners, people working on the restoration, is the report will be available, which we'll send to the PMT on Monday, this presentation and webinar. But for those members of the PMT and partners who might be able to use it in the interim, I don't really want to hold on to stuff. So we get a good deal on the imagery because of because I haggle with them. and so we can't distribute it openly, but I can give access to the imagery for the partners. That might be useful. That's Fish and Wildlife, California Fish and Game, the Coastal Conservancy, and we can make that available. We're hoping online in a way that people can see it and use it. And the data, I think you can request access to graphics or tables. I'm a little reticent to release the preliminary data before we finalize it this year. But I don't want that to stop people from, hey, could you give me the acreage of change in A21. It's easy for me to do. And if it helps with decision-making, I really want to open that up to the community. Next year, we'll produce our final report with our final data sets and interactive maps and another presentation and webinar. So that's everything I have. Does anybody have any questions?
Hi everyone. Thanks for that, Brian. That was great. My favorite part, other than your actual work, was reading the transcript. Cordgrass evidently is choreograph, according to the Zoom translation. Anyway, yeah. So if there are questions, comments, feedback for Brian, you can either use the hand raise function in Zoom, or you can just, well, let's try that. I see Donna has her hand up as a starting point. Go ahead, Donna.
Yeah. Hey, Brian, I know we talked about this previously, but I was wondering whether you've had a chance to go back and look at precipitation records. I think in particular with regard to the pepperweed, spear scale, and atroplex, those two, all those communities do shift. From all the mapping that I did in the South Bay for a number of years, and Gavins on the line can probably talk about this too. There is often a huge shift between those communities, and it seemed to relate to precipitation. So I was just wondering whether you've had a chance to tease that out or not.
No, and it's funny that, Donna, I have not, so it's on my list, and I don't, I haven't, but I brought out Gavin. I could just tell by the writing of the H.T. Harvey report from 2012. I was guessing that Gavin wrote that report. And because I tried to find some of them, and I haven't really had the time, and I don't, I really want to, but there's a lot to do, but I think it's something that we should do, if that makes any sense. So, and I did look through that report. Gavin, was that you who wrote that 2012 report?
I think so. Yeah, I did there was a final report that we produced for the city of San Jose. Looking at changes in species distribution across the marshes of the South Bay. And yeah, I think I did the final report of that series. Yeah.
And I will say that it was written very well. And well, and I say that because I could glance over it and kind of get the takeaways pretty good, and maybe because I'm familiar with it. And I think the takeaways are what Donna was saying about that variability. And I also noticed that a mention of shift into brackish in many places. And that was, 7 years before this, 7 years before this image. So it's somehow useful to know that it's been noticed elsewhere. I think that shift is hard to, on a if we do this once a decade, it's harder to notice, right? You don't know whether it is. That's why we do 2 years. So you never, and so we don't know. I haven't looked at the precipitation records again. But if we could compare the precipitation 2019-21 and then look at the differences in spear scale and pepperweed would be great. There's a lot on the plate. Like, I want to do everything. And I think I probably should do that, but I'm not sure if we can fit it in. The ISP stuff is really sitting that we have to put energy into on top of everything else. But Donna, I think it's a great comment. And I had it down, and I went and looked at that stuff because of those comments, and that's why I do the webinars, to get those comments, right?
Thanks, Brian. That's great.
Welcome. Yeah.
Brian, there's a question in the chat from Laura Cholodenko that says, you mentioned tracking erosion of mudflat edge. Any possibility to track erosion of marsh edge? And I don't know if Laura, if you want to elaborate on that, or if that's clear enough for Brian. Yeah.
No, Laura, if you want to, you're welcome, but I think I get it. And you're tracking erosion of marsh edge. We could, I haven't, a marsh edge on the fringe marshes, I haven't seen it, right? And we could be more quantitative in our ability to track that edge. And so most of it's qualitative at this moment. One thing that we're going to do for the final report is I purposely haven't included percent change or things that just show this area changed and just show the change and maybe show what it is. When we're going to do that for the final report, because we'll have the finalized data sets to do that. And in that process, I can look at quantitatively where we might see marsh edge changes within the spatial parameter. You know, there's some wiggle, you know, the images themselves aren't perfectly aligned, but they're pretty close, right? So we could do that. So it's a good comment. And so when I do those change graphics, I'll think about doing that quantitatively. Qualitatively, I haven't seen that, right? I see one thing that surprised me, and I'd love to get input from people here. Maybe it's that, like Alviso, I see the marsh growing into the slough. And I'm like, no, that must be wrong. And I checked it and I'm like, no, that's a real signal for sure. So maybe fingers crossed that we're not seeing erosion of the marsh edge, and that's enough said there, I guess. So
yeah, I was interested in, I guess those fringe marshes, you know, the ones that are sort of open to the bay and more prone to seeing a lot of wave action.
Yeah, it could be, and I just haven't looked in a fine-tooth comb, but I haven't seen evidence of that. Could be also the mud flats, right? You know, one, because the mud flats don't seem to be eroding. Jeremy, do you have a question? I see you. No.
Take it away, Jeremy.
Unmute. Hi, Brian. That was a great talk. It was really interesting. On the mudflats, do you see any variation within the mudflat itself between eroding and maybe depositing areas, comparing maybe with the areas that Bruce, Jaffe, and USGS point out between the convex and concave profiles and so on? Is there any information within the mudflat itself that you can pick up on your images?
So as far as convex and concave, we can extract that, but didn't yet. And so I can't really say anything about it with this data set, right? But we can explore it further, mine the data further to do that. And here's how we regress between the bathymetric data and the spectra, and it gives us an idea of concavity or convex. And also, you can see water pooling in the mudflat, which gives us an idea of where it is. Looking at changes would be harder, right? So first is that information is not presented here, but we can mine the data to get at that. The convex and concave shapes. As far as just horizontal accretion or erosion, you know, like in the mouth of Maori, I see an erosion from 2016 of up to about 60 meters, but it's very localized. And so is that interannual variability or not? I don't know. And I don't know about the concavity or the 3D nature of it, right? We don't know. But then in another location, in the center part of that South Bay, I see between 2016 and 19, where I think we have good control, some places eroding and some place looks like it's accreting, which could be normal interannual variability in that location, which is exposed to wave action. So I didn't really answer your question, but maybe I did.
Oh no, that's great. I was interested. I mean, yesterday we heard a presentation by Bruce Jaffe at the RMP sediment workshop where he talked about his bathymetric data analysis, and it's really and then of course there's lidar and so on. I was just wondering, it'd be great, one of the next steps might be to kind of start bringing those data sets together.
I think you're right on there, and we do. So we use their Coyote Creek data, and so their Coyote Creek stuff we use to get an idea of where the edge is and the mean lower water line is, and change. So, and I'm not saying that only I want to say that a lot of our work is dependent on Bruce's and Amy's work. So, but I think combining them more would be better.
Thanks for that, Brian. We have 3 hand raises in order. Kristen
Okay.
Bird, then Rachel, then Gavin. So Kristen, unmute yourself and take yourself off camera if you like. You don't have to. You're welcome
Sure.
to. Go ahead.
Thanks. Hi. Yes. Thanks. That was a great talk, and it was really great to see the updates. And I just wanted to announce. So I'm working on a project with Susan De La Cruz and Isa Wu and others at USGS, and CSU Monterey Bay on hyperspectral mapping of the biofilm quality, getting at some more detailed characteristics of the biofilm as it relates to its nutritional quality for the shorebirds. So I just wanted to let you know that on April 15th, as part of this, we were able to capture a Averus NG 4-meter hyperspectral image of pretty much the whole South Bay. I don't know if it includes all the ponds, but definitely the mudflats and most of the project area. So NASA JPL is doing the post-processing on that, and that'll be available to the public. So it may be a resource for this effort. Just want to let you know it's out there.
Great. Thank you.
Yeah, that's very helpful. Rachel, go ahead.
Yeah, hi. So I wanted to kind of go back to Donna's comment about the drought and how precipitation is related to some of the imagery, and how that's part, like the reason that we have a lot of folks on the call today is because a lot of these questions won't be answered by Brian, but that they are available for others to look at what we're seeing and saying and getting those questions answered. So people looking at it and going, well, why is the marsh accreting at Coyote Creek? And maybe that's something that we already have data on, or we can work with Brian's data to start looking at those questions. And so I think, you know, this gives us an opportunity to really see where things are happening, and an opportunity to see where some future research could go. So I think Brian does a great job to provide this information to us, and at a smaller scale as well, so you can get into the details of by location. I think it's great that we have the marsh accreting down at Coyote Creek, and I think, you know, we don't see most of the time when we say we're having new marsh, it's just from restoration projects. It's by breaching an area. So to be able to document that we're having marsh being created at Ogilvy and whatnot, like that's an important thing that you don't really see in a lot of reports about new marsh being created outside of a restoration area. So I think that's a great thing to capture. And then the last one I had was Olafson Environmental and Calypsy have noticed that we have a new invasive coming in the South Bay in the last 2 years or so. So it's a Papillum vaginatum. And so we're going to start mapping that this year and hopefully some next year in the Island Pond area. And so I think this is going to be a great one to, again, if we can use that imagery from 2021, maybe the 2019 to see, is it new? Is it not? Does it show up in the imagery? And so we'll definitely be checking in with you once that gets started. So thank you.
Thank you. Great comments, Rachel.
Yeah, that paspalum has the potential to be a real monster if we don't sort of come to grips with it quickly. So it would be great to be able to, you know, use this as a remote sort of early detection method if possible. Gavin, go ahead. And then after that, there's a comment in the chat from Cheryl that I'll trust you to answer directly, Brian. Go ahead, Gavin.
Okay, thanks, Ed. Hi, Brian. Really exciting project and great to see these results. And I had one question about your finding of expanded low marsh in 2019 relative to past years. And I was wondering if you've had a chance to or plan to like tease out how much of that is from colonization of, you know, mud flats through the project, and how much of that, if any, is from conversion of sort of higher elevation marsh into low marsh. Just thinking about how this data set provides a really interesting, you know, sentinel project for looking at sea level rise changes in marshes, and to what extent your data is showing anything about that.
Well, Cheryl, I hope this is okay. Gavin, that's a great question. And Cheryl also asked a similar question: can the data be used to project sea level rise? So I hope maybe I'll get at Cheryl's question. I haven't parsed out the two, but I think we should, and if we can. And I think my instinct, this is just instinct, is it could be odd. It's hard to know about the restoration activities, right? But when I look at the data, it's just qualitative. I kind of feel like the low marsh is getting, it seems to me that sea level rise has an impact on it and on what's going on in that marsh. And so what areas that might have been higher slightly are now lower and even up in the marsh. So there's more cordgrass up into that marsh sometimes, as well as growing, right? So I'm thinking out of my zone here, but I think it's a great question. And I've been thinking about that, and I haven't addressed it directly, but I think we could use the data to do that. So it's a really good question. The other thing, Gavin, before I forget, is we mapped limonium. I think of you, not in a negative way, and it mapped pretty well, but I decided not to include it as a separate category.
Oh, interesting. Yeah. I know Galaxy will be excited about that because they're doing such a great job on their control efforts.
Yeah, agreed.
I just wanted to, Cheryl, I think that Brian spoke to your question, but please let us know if you were trying to get at something different. I would point out to everyone that Kristen Bird just put a link into the in the chat window where you can get the Avarice hyperspectral images if anyone wants those. And Simon, I see that you have your hand up. Please unmute yourself and go ahead.
Yeah, thank you, Brian. That was really interesting talk, and I'm very interested in able to identify plants remotely. A couple just quick thoughts is that at North Creek Marsh specifically, I think a lot of the restoration work that had been done to plant native Foliosa there has really taken off. So that's probably mostly Foliosa.
Okay.
And pickleweed. And then looking at A19, like any sites like those where there's a lot of mudflat and maybe one thing coming in, one plant coming in, I wonder if it's maybe easier to identify those plants when there's in theory maybe only one thing. Like the bulrush example was really cool. I will say I wanted to just throw in there that Elaeochris parvula has been spotted en masse down there, which is a really cool ranked 4 plant that we don't see a lot of, that could be confused with biofilm. And so just kind of throwing that out there.
Huh. And I'd love to hear more about that. Yeah.
Spear scale, may I ask what is the species of, what's the Latin name for your spear scale in your?
Well, it's the Atriplex, and we included more than one type of spear scale in,
cool. Okay.
in the mix. So it's the same species we used last time. So,
I'll check on that then. Thank you.
And it just escapes me at the moment. But this time it included more than one type of spear scale that I lumped together based on our ground truthing.
Very cool. Thank you.
Sure. Good question. And I'd really like to hear about the plant that you think could be confused with biofilm. So if you could email me, it would be great. So thanks for that comment. Yeah. Thanks, Simon.
Well, everyone, it is 11 o'clock. I don't see any other hand raises except for Gavin's, which I think might just be a legacy hand raise, or do you have more? No? Okay.
I do, but no, that's a legacy hand raise.
Okay. Well, thanks everyone. Thanks to Brian for this excellent talk and for all of your good questions and comments. I always enjoy these discussions. And Brian's email is on the shared screen here. So there's at least a couple of interesting conversations that warrant some follow-up. So I hope you all will do so. And yeah, thanks for taking time out of your Friday, everyone. Have a terrific weekend.
Yeah, thanks everyone. Really great questions.
Yeah, we'll get this posted on our website pretty soon, and we'll have a link to it maybe from the Facebook page. If you're on that, you'll get a notice when that's up there. So thanks to Ariel for her help, and thanks to you all. Have a great weekend.
Thanks, Dave. Have a great weekend.
Thanks, Brian.